Hello and good morning. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this morning's video tutorial is going to be on basic redistribution. So we're going to be taking a look at redistributing from EIGRP into OSPF and from OSPF into EIGRP. And these are actually some absolutely fantastic exercises. So definitely run through these. If there's something that you don't understand, run back through it again to make sure that you have everything down. But again, these redistribution activities are absolutely phenomenal. So this is the topology that we're going to be working with. You can see that we've got quite a few networks here, or quite a few prefixes representing networks as loopback addresses. So let's dive in here to step one. So what we're going to be doing here on step one is we're simply going to be redistributing from OSPF into EIGRP to start things off. And so again, you can see that router 1 here is definitely a boundary router, right? So router 1 is definitely a boundary router, and it's got OSPF v2 and v3 networks over here to the left, and it has EIGRP v4 and EIGRP v6 networks over here to the right. And so this is going to be a single point of redistribution. So in this scenario, we really aren't at risk of routing loops because we're doing single distribution. Now remember, from the reading in chapter 4, if we had another router here, let's say this was router 5, and we were doing redistribution this way, and then this way, and this way, then we are at risk, and that's when we're going to start to talk about route maps, and even tagging the routing information that's being redistributed so that it could be filtered and then not redistributed back the other way. All right, so let's go ahead and dive into this basic redistribution setup here. We're going to start on router 1, and let's take a look and see what the routing table looks like right now. So let's go from user exec into privilege exec, say show IP route OSPF. And you can see we've got a number of inter-area, the OIA OSPF routes. And we have a single intra-area OSPF route, which is that bottom 192.168.11. What about show IP route EIGRP? As you can see, router 1 has learned 4 EIGRP networks, the 10, 10, 11, 12, 13, and 14. So the 172.16, it's 11, 21, 22, 23, and 24. So you can see we're learning these here, right, on router 1, and they're coming in as OIAs, and my guess is they don't show, they show the processes but not the areas, so we'd have to take a look at the areas here to see, but my guess is these are in a different area, which is why they're showing up here, even though it doesn't show it here on the diagram. And then here's our 10, 10, 11, 12, 13, and 14. And so we're basically going to redistribute that information. These 1010s are going to get sent into OSPF, and these 172.16s are going to get sent into EIGRP. So back here on router 1, let's go ahead and get into global config, and we're going to say router EI, and actually what do show run section EIGRP. Let's see what EIGRP process confirm here. So router EIGRP 100, you can see we've got that single network statement on router 1. So let's go ahead and say router EIGRP 100. Now, basic redistribution. So, and I'm going to talk through how I translate it into English anyway when I'm taking a look at it, because sometimes it can become a little confusing for learners seeing redistribution for the first time and trying to figure out, well, how do I know what's being redistributed into what? What direction are things going? So I'm basically saying here is redistribute from OSPF the routing information that's part of OSPF domain, or process ID 10, I should say, into EIGRP 100 on this router. Remember, redistribution should be looked at in the outbound direction, in the sense that I'm redistributing from OSPF. And so that's how I read this comment, or read this command. It's redistribute from OSPF all of the routing OSPF information and process ID 10 into EIGRP Autonomous System 100. Now, since we're redistributing from OSPF into EIGRP, remember, we're talking about apples and oranges here in terms of the metrics. We know that EIGRP uses the composite metric, which by default is simply bandwidth and delay. And then we know that OSPF is using its metric, which is simply based on the bandwidth of the interface and then the speed of the link, right? So when we take a look at OSPF, the metric there is a little simpler than the metric in EIGRP, but the point is that those two metrics are incompatible, which means when I'm redistributing from OSPF process ID 10, I need to assign EIGRP-like metrics, right? So I need to give this routing information that's going to be coming from OSPF process ID 10. I need to give it an EIGRP set of metrics, right? So the bandwidth, and typically what you'll see is 1500, then the delay 100, the reliability 255, the bandwidth where loading is simply 1, and then the MTU of the path. Keeping in mind, we're putting the MTU in here, but keep in mind that MTU is not used in EIGRP metric calculations, and it is not used as a tiebreaker of any kind. So remember that. So again, what does our statement basically say here? It says that we are going to redistribute from OSPF process ID 10. So all the routing information that is currently on this router, and again, this is we're talking about router 1. So everything that router 1 has learned as a result of OSPF process ID 10 running on router 1, we are going to send that into EIGRP Autonomous System 100. So we're basically sending this OSPF information, all of these prefixes that we've learned from OSPF process ID 10 are going to be shipped into EIGRP 100, and this is the metric that is going to be assigned to each and every one of those prefixes that get redistributed. Okay, so because we have to do that, we have to put the metrics on here so that when EIGRP Autonomous System 100 receives this OSPF routing information, it's going to look at it and say, aha, so I'm getting some new routing information which are going to be DEX or EIGRP external routes, but I know what their metric should be. Therefore, I'm going to welcome them aboard as external EIGRP routes. All right, so let's clear the screen here. And again, this is a very simple case. If I were to do a question mark, you could see that we have a route map command here. And from the reading in Chapter 4, you'll remember that route maps are going to start to play a very important part in the information that we are trying to manipulate, especially at layer 3 and especially when we get into BGP. So again, it's just redistribute from OSPF process ID 10 and assign the metric, right? Give a composite metric to that routing information so that when it goes into EIGRP Autonomous System 100, that process, EIGRP AS 100, says, oh, okay, I recognize these routes. All right, so we're going to hit enter right there. So we just redistributed from OSPF, so over here from OSPF into EIGRP. So let's come over to router 2. Let's get into privilege exec and say show IP route EIGRP. Well, take a look at all of the 172.16 information that we now have here as DEX routes. There are my 172.16.11, 12, 21, 23, 24, or I'm sorry, 21, 22, 23, and 24, and then this 192.168.11. If we come back over here, you can see that we're picking up the transit links. That's my 11 and my 12, right? So we get the transit links here in this OSPF domain. but we also get the 172.16s, and then we pick up this 192.168. Now, the key thing to notice here is that none of these routes come in as OSPF, and none of them have an OSPF metric. That is clearly an EIGRP metric. And again, this is a classic autonomous system mode, if you will, metric. So this is not the named mode, although we could do redistribution into a named mode process. That is not what you're seeing here. So again, you can clearly see these are EIGRP metrics, and we've picked them all up as DEX. So external EIGRP with an administrative distance of 170, and now this routing information is now available in the EIGRP domain, and it's available because we have redistributed it from the OSPF domain. Okay, so now let's go ahead and we're going to do just or actually we're not going to do the opposite. We are going to do the OSPF v3 information. So the IPv6 information is now going to be redistributed between OSPF, and this is process ID 20, and we're going to redistribute that information into EIGRP. Remember, redistribution takes place in the outbound direction. All right, so back here on router 1, let's say, whoops, sorry, let's pull that back. Let's say IPv6, router, EIGRP, 200. So again, it's very similar when we're redistributing with IPv4 as to when we're redistributing with IPv6. Now, we're going to talk about the include connected because that is definitely something that I can see that may trip you up at some point in the course. So we simply say redistribute from OSPF process ID 20. Again, redistributing in the outbound direction. So from OSPF into EIGRP, and we need to assign the same metric. So we're going to say 1500, 100, 255, 1, 1500. And again, these values are pretty much insignificant. They're not that important. And again, those are just some common values that you could use. I could have said 10, 20, 30, 40, 50, and it's going to show up over there in the EIGRP domain and still have an EIGRP 32-bit metric assigned, right? So, but again, these are common values that get used. Now, you'll notice that we see an option here that we didn't see before because we are doing IPv6 redistribution. And it's this argument right here, this include connected. And what the include connected means is if the transit interfaces are to be included, right? Those, and what was over here on router 2 was 172, yeah, so if, and I'm showing you the IPv4 addresses here, but this is, remember, these are the transit networks. So 172.16.11 and 12, those are transit networks. If I wanted those connected networks in IPv6 to be included, I would say include connected. However, typically you aren't routing to a router, you're routing to something behind the router. Now, that's not to say that there's no value in redistributing those transit networks, but typically you don't. Even for management. Typically for management, what kind of an address would you have assigned to the router? Exactly. You'd have a loopback address assigned to the router. So you certainly can include the connected. We're not going to here. I think we do later. But know that it is there because you may be shown a section of a show IPv6 route command, and you may be asked, you know, which command would result in the routing table looking like this. And if they have the connected networks there, then you're going to want the include connected. And so in our case here for this IPv6 information, we should not see 2001 DB8 05/64 or 010. So these are my connected transit networks. So let's see if this holds true. So we come over to router 1, and actually before I do that, let me come over here to router 2, I should say, and we're going to say show IPv6 route EIGRP. So as you can see, we have no IPv6 EIGRP routing information over here yet. Again, we've got some loopbacks, right? But nothing other than that shows up. So let's go ahead, let's kick off the redistribution here. I'm going to hit enter. We come back over to router 2. Let's rerun that command. Aha! So now we see a whole bunch of routing information. And you'll see that we pick up, and did we pick up the 5? We see the 5 there, but we do not, oh, I'm sorry, connected from router 1. I apologize. So including connected, right? Not so much the transit networks. It's going to be the connected interface on router 1. So that's why we're seeing, whoops, that's why we're seeing, let's get this back up here. We do see this because it is not directly connected to the router on which we are doing the redistribution. My apologies there. So this is the guy right here, because that is an IPv6 address on that interface. This we will not see, right? That is the connected. So when I say include connected, I'm talking about this transit network. And if we were redistributing something from here from router 4, then it would be that. But we are not doing redistribution from 3 or 4, so we will see the 5. Apologize there. Okay. So back to router 2, we can see that we get everything except for that 10 network because we are not including the connected off of the router on which we're doing the redistribution. And again, everything shows as EX, meaning external EIGRP. Again, administrative distance of 170, and we've got our EIGRP composite metric, which is based off of the metric statement that we included on router 1 when we did that redistribution. So now what we're going to do is we're going to configure router 1 one more time here, and now I am going to say include connected, and we are going to see that 10 network. So let's pull up the show IPv6 route EIGRP, and because it is directly connected on the router doing the redistribution, we will pick up that transit segment, right? And again, typically you don't see the connected, or you try not to put the connected in there because you're not routing to that router, you're routing to something beyond that router or behind that router. All right, so that information shows up now. So now that we've completed the redistribution of both IPv4 and IPv6 from OSPF into EIGRP, what we're going to be doing now is just the opposite. We're going to be redistributing from EIGRP into OSPF. So let's jump back onto router 1. And again, all of this is happening on router 1 because router 1 is the only router here that has visibility into both domains. It sees everything from the OSPF domain, and it sees everything from the EIGRP domain. And again, this is a single point of redistribution. So if we get back onto router 1, and actually let's come over to router 4. So on router 4, let's go from user exec to privilege exec, and we're going to say show IP route, and actually we want to do show IP route OSPF, sorry about that. And you can see we've got those two transit networks, or a loopback in one of the transit networks, and then show IPv6 OSPF, show IPv6 route OSPF, and we've got those two networks there. Again, the 10 is a transit network, and the 192 is, I guess, a loopback. Yes, this loopback right here, loopback 1 hanging off of router 3. So again, we're seeing some limited OSPF information that is germane to this OSPF domain. But now what we're going to do is we need to get this routing information over here on the right-hand side. We need to get that into OSPF so that things behind router 4 and router 3, and obviously router 1, since that's sort of the border router, they need to be able to see and have IP reachability to these IPv4 and IPv6 networks. And so the only way to do that, because router 3 and 4 don't currently see any of that information, is to redistribute it. So let's go ahead and let's make that happen. And again, it's a very straightforward case here. We're just going to say router OSPF 10 because that was our process ID. And now remember, redistribution in the outbound direction. So redistribute from EIGRP Autonomous System 100. Now, we can assign a metric on this redistribution. I can assign a metric type. Now remember, the metric type, we're talking about an OSPF specific metric type, because with EIGRP, what did we see? We saw the metric argument, we saw the route maps argument, and that was about it when we went to do the redistribution. And then we saw the include connected with IPv6. Excuse me. But when we're looking at redistributing into OSPF, first off, what is the seed metric when we redistribute into OSPF from anything else, with the exception of BGP? The seed metric is going to be 20, right? And that's what we're going to see here, is that the seed metric is going to be 20. Now, one thing that needs to be included here is this subnets command. And I've been bitten by this a couple of times in my career, where I've redistributed into OSPF and left off the subnets argument by mistake. And so let me tell you what's going to happen when you leave the subnets argument off, is that you will only redistribute classful networks. So that is networks that are on router 1 and that have a classful mask from EIGRP Autonomous System 100. Only with a classful mask will those networks get redistributed in. So if I leave the subnets argument off, chances are you're not going to get too much, because typically you're not doing things at a classful boundary. You're doing classless subnetting, right? You're subnetting things. So I would want to say subnets. So let's come over to router 4 over here in the corner, and let's take a look at show IP route OSPF. And you can see we don't get much. We've got nothing yet, right? What about router 3? What does router 3 see? Show IP route OSPF. Aha! So router 3 is actually seeing additional information. And what is the seed metric here? Right? The seed metric is 20. And by seed metric, I'm simply just, it's a fancy way of saying the default metric value that is going to be assigned to these OSPF routes, or I should say to these EIGRP routes as they are injected into OSPF or redistributed into OSPF. And so when we did the metric command on the opposite side, going from OSPF into EIGRP, we were simply assigning a seed composite set of metrics that would be assigned to those OSPF routes as they are injected into EIGRP or redistributed into EIGRP. But the administrative distance, does it change? It does not. The administrative distance is still the same. It is still 110. And so now I'm curious. Okay, I was going to say I'm curious as to why we didn't see that information on router 4. I was getting ready. We're going to have to dig in and do a little extra work to figure out what was up. But it looked like it's just the simulator taking some time to get it in there. But again, take a look. It's OE2. Now, this is a critical point of importance here. This OE2 versus OE1. And you can see we have the same conversation when we're talking about the NSSA, the not-so-stubby area, or the totally stub, not-so-stubby area. And you can see here that when we have things that are being redistributed into a non-stub EIGRP area, they are going to show up by default as OE2. And so what does that mean? Well, E2 means that it's going to go in with a seed metric of 20, and the administrative distance will always be 110, right? Because that represents OSPF. But the seed metric will be 20. And the seed metric will be 20 irrespective of how many internal hops and the internal costs that would be associated with this route. It's irrelevant. When it gets redistributed in and we leave it as default OE2, right? Or I should just say, as we leave it as default, E2 as a metric type. That means external type 2. That means it's going to go in with a seed metric of 20, and it doesn't matter how many internal hops I have to take or that I am taking. Because remember, we're on router 4 when we display that output, and router 4 says that the cost, the metric is 20 to reach that information. But I'm redistributing from router 1, and you can see it has to come across this Ethernet link here, and then it even comes across a slower serial link, but yet I still see the cost is 20. If I come up here to router 3, what's the metric going to be on router 3 for that information? We already saw it, right? Take a look, it's right there. 20. So that is what OE2 is all about. The external type 2 gets the seed metric assigned, and the metric is 20 and will always stay 20 unless you manipulate it to be some different metric value. Now, that's what we call cold potato routing. And you'll hear these terms all the time. Hot potato, potato, cold potato, potato, I hope that's how you spell that. Hot potato, cold potato. E2 and N2, where did my N2s go? N2, these are known as cold potato routing because everything is given the same metric when it is redistributed into, in the case of E1, E2, into a non-stub area, and in the case of a stub area, N1, N2. And so those are referred to as cold potato. Both of these are referred to as cold potato when we're redistributing things in and we're not taking into account the cost of the internal links. Because again, in the environment that we have here, it's not that big of a deal, right? Because there's only one way for router 4 and router 3 to get out. So does it really make sense to take into account whether or not, or I'm sorry, to take into account the cost of these internal links? And it's not really a rhetorical question, right? It really doesn't. But when we add a second boundary router, and router 4 is connected into that guy, and that guy redistributes over here, and we'll say this is router 5, now does it make a difference? Yeah, now it does. Because now we have two exit points out of the environment, out of both sides of the environment, right? We've got an exit point from 5 over into EIGRP and an exit point from 1 over into EIGRP, and vice versa, right? So we've got two ways to go into and out of each of these areas. And you can see that what does this look like might happen, and that's asymmetric routing, right? Where the traffic comes over to router 3, but then my return traffic goes through 4 and 5 back over here to 2. And that's what we call asymmetric routing. So in the scenario that we have right now, it doesn't really matter. There's only one way for 4 and only one way for 3 to get to all of this information that's being redistributed from EIGRP into OSPF with that default seed metric of 20. And these are the scenarios here where you have a single exit point where it's okay to do cold potato routing. It doesn't make a difference because we can only come in and only go out in one direction. So the fact that everything is 20, no big deal. Again, keep in mind as we move to more advanced scenarios, and let's say that's an Ethernet link actually, and that's an Ethernet link where this becomes an important conversation of changing the metric type to E1 or to N1, right? Remember, this is redistribution into a stub area, an NSSA stub area, right? And this is redistribution into a normal EIGRP area. And so when we look at this, I say normal, I mean non-stub. And so when we look at this, the difference is this, is that when it gets redistributed in, it's going to come in with a metric of 20, but then we're going to add the cost of the additional links. Okay? So it gets redistributed, but now I'm adding the cost because it does make a difference as to which exit point I'm going to use. And so then I need some way to differentiate the OSPF metrics going that way and going this way. With E2, I don't get that. Everything is 20. So everything looks the same. With E1, I'm now saying, no, hold on a second. I see we've got a serial link over here. That is of concern to me. Let's add the metric cost of that link into these redistributed routes so that we can take that into account so that we can make a more informed routing decision and go out the fastest potato. I'm going to make sure we spell potato right here. Hot potato path, right? And this is what we call hot potato routing. When we have E1 and N1 metric types with OSPF, that is hot potato routing because it is going to take a look at the two possible exit points and say, I'm getting it out as fast as I can. We're taking the shortest metric out of here. It's a hot potato. And if you have never played the game hot potato, it's where, you know, you hand a hot potato around and you get rid of it as quick as you can, right? Because if you hold on to that hot potato too long, it's going to burn your hand. So you're moving it as quick as you can. And that is what E1 N1 is all about. And so that's the difference. And I believe we're going to see that here in just a second. So we said redistribute EIGRP 100 subnets. Now, let's see what happens if I were to take off, and actually let me say this here. Let's say subnets and Control A, and we're going to say no, redistribute EIGRP 100 subnets. So now let me come back over here to router 3 and let's see, what do we see now? So all of that OE2 redistributed information is now gone. We no longer see it. So now let's do this, and the reason I'm setting this up here is I want to say, here's what it looks like when I don't have subnets on there. And I've actually done this in practice before and literally kicked myself later. So you can see, right, we don't get anything. Because the subnet information, right, or I should say the routing information we're trying to redistribute isn't classful. It doesn't have a classful /16 mask. I believe we're doing 172s. Let's go back up here. How long ago did we? There we go. There are these 10 dots. They don't have a /8 network mask. They've got a /24. So they're subnetted. So this could be a problem, right? Even this 172.16, right? It's a /24. So those are not classfully masked networks. Therefore, when I leave the subnets option off of my redistribution statement, we end up with this, which is nothing being redistributed in. So let's come back to router 1. We're going to say subnets, and now for whatever reason, let's say that I wanted to change the metric, right? So I could say 99 and hit enter. Now, what I've just done there is I have changed the seed metric. By default, remember, it's going to be 20, but I've just changed the seed metric to 99. So when we come back over here to router 3 now, we've got the subnets option in there, and the metric has been set to 99. And let me make sure that I have to remove do show run section. My guess is that, so my guess is that the redistribute command I ran prior to this is still in the config, which is not with the subnets option and not with the metric 99 option. And it is not. Where are we at here? Redistribute OSPF. Oh, sorry. Do show run section EIGRP. And it's very easy to get turned around here as you're trying to look at what you're redistributing and where you are redistributing things into. All right, so we've got the redistribute OSPF metric 10. So we are good there. Or no, we are not good there. Redistribute EIGRP. Did I actually type the wrong command? Redistribute EIGRP 100 subnets. And it looks like the command didn't even show up there. Let's take a look here at our OSPF configuration section. And let's see, on router 1, it's not even there. All right, let's make sure we're getting this done properly here. That's interesting. So we're going to say router OSPF 10, redistribute, EIGRP, 100, subnets, metric, and we're going to say metric 99 is what we're going to set the metric to. I'm going to hit enter. And that should get us back to where we're going to see things, and there we go. Okay, so I must have typoed something earlier. So again, you can see that the seed metric, I changed it. I said make it 99, but it's still OE2. And so a quick note, right, and we kind of talked about this briefly. Let's get back over here to router 3. We talked about this briefly last week, is remember that intra-area OSPF routes will always be more preferable than inter-area OSPF routes, which will always be more preferable than OE1, ON1, and actually I don't need the 1 there, or I'm sorry, the O. So E1 and N1, so inter is more preferable than E1, N1, and then E2, N2. So intra is better than inter, is better than E1, N1, is better than E2, N2. So these down here, these E2, N2s, out of the 4 we've listed here, these are the least preferable. And it makes sense if you think about it, because this is cold potato right here. We're not taking into account any of the internal costs associated with the redistribution in either case here. But here we are. So these E1, N1 would be considered more trustworthy or more reliable because they've got additional, more granular metrics, because they are taking into account the cost of the internal networks. Whereas E2, N2 aren't. They don't care. Everything's 20 and we're good, right? So remember that hierarchy right here. Intra over inter over E1, N1 over E2, N2. All right, so let's go ahead and scoot along here. We've got our subnets in there, and we tweaked it to 99. We talked about the OE1, OE2 types, and now we're going to see that in action, and it just so happens that we are going to be doing that again off of router 1 here. And let's see, I wonder if this is a bug. If I take this off and then I say metric type, right? So now we're going to change that metric type, because remember, up until now, over here on E4, what do we see? Everybody's got the metric of 99, and we're removing that now. We're going to let it go in as a default of 20, but what we should see is that it doesn't stay 20. It's going to change, because now we're saying we're changing the metric type here, and we're going to change it to 1 to make it a type 1, so an OE1. Now it goes in with a default seed metric of 20. When we come over here to router 3, what do we see? That it went in with the default seed metric, and now it's at 109 because it comes off of router 1 and it gets redistributed. It gets redistributed in. So router 3 sees it, and we add the cost of the interface. And now let's take a look down here at router 4. So we come all the way down to router 4, and we're going to say show IP route OSPF. We're going to see that information and take a look. So it's incrementing. The metric is incrementing as it makes its way along the path. So from the point of view of router 4, the cost, or the metric, the OSPF metric, is 173 now. It's no longer 20. And so this is that hot potato routing, because now router 4, if it had another exit point to get back to those networks, now has a realistic view of the internal costs that are being added on so that it can make the best and fastest hot potato decision to get that packet to pass it on as fast as it can so that it doesn't get burned by suboptimal routing. Okay? All right. And how could we add this up? Well, let's take a look. If I was to say do show IP OSPF interface, and I can't remember if that's Ethernet 00. Yeah, it's not on there. Interface, let's just do interface. So let's see. So, Ethernet 01. So you can see here the cost on Ethernet 01, right, in the outgoing direction, and here's Ethernet 01, the outgoing cost is 10, right? So we look then at R3 and take a look at R3's outgoing interface cost. So we come over here to R3, and we say show IP OSPF interface. And the outgoing interface, where are we at, and what interface was that? I apologize. Serial 10. So serial 10, excuse me. And you can see that the cost is 64, right? And then we've got the, excuse me. And then we've got, excuse me, I'm going to get something to drink here real quick. Hold on just one second. All right, sorry about that. Started to get a little sore throat action going on there. So anyway, so what we're seeing is we see the sort of aggregate cost, right, of all of the links. Now, the little bug that I shouldn't say a bug, but the behavior that I was talking about, do show run section OSPF. Let's take a look at the section here. You can see that we've got this metric type 1, but it left it at 99 even though I had taken that off. So, or I should say, even though when I re-entered the command that I didn't put a metric in there. Remember, I just typed in redistribute EIGRP. That's what I typed in, but it left my metric setting from before on there. So when we take a look at this, we see down here on router 4, the cost is 173. And so how is that 173? Well, remember, when I redistributed it in, I said my seed metric is 99. The cost of that interface is 10, and the cost of this outgoing interface, this is 109 together. If it's 173 total, the cost of this is 64. And that's how we do the E1 and N1. Remember, this is a non-stub OSPF domain here, right? So we're getting E1s and E2s because it's non-stub. If we were an NSSA, we would get N, and when I say non-stub, I mean non-NSSA, because you can't have the type 5 information in the stub, or, well, you could pull it out of there if you do the totally stub, but typically you don't see the OE1, OE2s when you're doing a totally stub, and you don't see them in the NSSA or the totally stub in SSA. So N1, N2, right? And we take into account the cost of that outgoing link. We take into account, we add in the seed metric, and we take into account the other outgoing link. And again, we're from the perspective of router 4 here. So router 4 sees 173. So if router 4 had an Ethernet link there and an Ethernet link there, and we were doing redistribution at multiple points, 4 would say, going this way, my cost is 173. Going this way, if these are Ethernet links and the cost is 10 and 10 with a seed metric of 99, we're looking at 119. Is that right? 109? Yeah, 119. So then router 4 would say that based off of the the E1 metric, I'm going to go this way to get back to that network. And that is hot potato routing, where we want to have as much information, metric information as possible to make an informed decision. And again, when I hit enter and I entered that command and I say do show run section OSPF, keep in mind it kept my metric value in there. So make sure that you're aware of that. To go back and take a look at that OSPF section one last time to make sure that if you were making additional changes that you end up with the result that you want. All right, so now let's go ahead, let's wrap this lab up here. If you're following along, I'm on step 11, and we're just basically going to now do the IPv6 information. So we're going to say IPv6 router OSPF, OSPF 20. And we're going to redistribute EIGRP, Autonomous System 200. Now remember, we're talking about IPv6 here, so we've got this include connected. And remember, it's going to be the connected network on the router on which we're doing the redistribution. So we're talking about that network, or wait, I'm sorry. I'm going the wrong direction. We're going from EIGRP into OSPF. So this EIGRP network, so 13. So if I were to come over here to router 4 and say show IPv6 route OSPF. Because remember, I say OSPF because even though we're redistributing from EIGRP into OSPF, they become OSPF routes. They don't stay as EIGRP routes. So you can see we don't see a 13 here. So let me come up here and I'm going to do it without the include connected first. And then let's come back to router 4 and let's rerun that command. And I guess we're going to have to give it a second here. There we go. Boy, it takes a little longer than I thought it would here in the simulator. So anyway, we get the information we're looking for, right? But do you see, or actually we do see that 13 network. Is that right? Let me take a look and make sure. 2001 DB8:0:13:/64. Do we see that network? 2001 DB8. Oh, 10. I'm sorry. That is not the same network. Aha. Okay, so they've got a 1013. I saw the 13 and triggered thinking, why are we seeing that? So we do not see this transit network, correct? There's no other 13 listed in here because we did not say include connected. If I change the command and say include connected and we come back over to router 4, what should we see? There should be a second 13 network, and there it is right there. Now, a couple of things to note with IPv6. Same administrative distance for OSPF, same default seed metric of 20. So irrespective of whether we are redistributing IPv4 information into OSPF from another routing protocol, well, let's say from EIGRP. I need to make sure I'm careful here because when we start to talk about BGP, it's going to be a different value. The seed metric is going to be different. When we redistribute from EIGRP into OSPF, we end up with a default seed metric of 20, and that is irrespective of whether or not it's IPv4 or IPv6. Now, it's the exact same thing when we talk about hot potato, cold potato. We can simply change our redistribution command and say redistribute, and let's see if this happens again. EIGRP 200. Metric type, we're going to change it to 1, and we're going to say include connected. Now, let's go ahead and we'll leave the, instead of making it 99, the seed metric, we'll leave the seed metric as 20. Now let's do a do show run section OSPF, which is where we're doing the redistribution from. And here you can see metric type 1, include connected. We come back over here to router 4. Now we should see a different, I shouldn't say a different seed metric. We're going to see a different metric because it's going to be the seed metric in addition to the cost of each of the outgoing interfaces to get to router 4. Because remember, router 4 is the router we're on. We're going to look at things from the point of view of router 4. And here we go. You can see that for all those loopbacks, and here are the loopbacks, they're now OE1s. So 11, 12, 13, and 14, and the seed, or I shouldn't say, keep saying the seed metric. The seed metric, in addition to the individual costs of each of the links to get to router 4, is going to be 94. And that allows us to make a more informed hot potato routing decision because now I've got more specific information. And why is it 94? Well, if we come back to the diagram, it's 94 because I redistributed in with a seed of 20. The cost of the Ethernet link is 10, so that gives me 30. And again, the cost of the outgoing interface on the link. And then the cost of the outgoing interface of the serial link is 64. And that gives me, from the point of view of router 4, a metric of 94, and that looks like 914, sorry about that, a metric of 94 to get to any of these IPv6 routes from router 4's perspective. From router 3's perspective, the cost is 30. But still, this is hot potato routing. If we had another redistribution point here, then this would be, you would want to go with E1 metrics. And if it was an NSSA, you would want to go with N1 metrics, because you would want to make sure that you are taking the optimal path out of your network. And in order to do that, you need to differentiate the metric costs of each of the internal links that are going to be required that you go over in order to reach that final external hop taking you into that EIGRP domain. All right, well, this is sort of our introduction here. We've got a number of other activities we're going to be doing, and I'm telling you that the Cisco Learning Labs activities are absolutely fantastic in all the chapters, and specifically here in Chapter 4. All right, thanks so much for watching, and I will see you this evening at 6 o'clock.